Hello again, my dear students. Welcome back to our class. So for this week's lesson, we will be talking about periodic motion, mechanical waves, and sound. So basically, lesson 2 is all about waves. Just like lesson 1, this video will serve only as a guide or as your guide in the calculation process. Also, let me inform you ahead that some sample problems are not included or will not be included as they are self-explanatory, meaning they can be easily understood. However, if you still have questions regarding the problem or the solution in the book or the lesson in general, you can always message me. Palihog lang kung naamoy nalibgan, PM dayon. Kay mo reply rako. Maningkamot rakog reply. Okay? So, I hope I made everything clear enough here. So, I guess it's a good time to start. Alright, so let me bring you directly to sample problem 8.2. A simple harmonic oscillator consisting of a 2.5 kilogram body is attached to a spring with a force constant of 275 Newton per meter. Its maximum speed is 0.65 meter per second. Find its amplitude. That's the first one we need to find. And the second one is the maximum acceleration. So let's first summarize the given. We have here the mass, which is 2.5 kilograms. Find amplitude. Note that the velocity of the oscillator will be maximum if x, or its displacement, is 0. So using equation 8.7, we have here v equals square root of k over m multiplied to the quantity of a squared minus x squared square root of k over m. Alright, so this is equation 8.7, which is necessary for us to solve for the amplitude. So from here, as we said, the velocity of the oscillator will be maximum if x is 0. That means this one right here will be equal to 0. So our equation will become v equals square root of k over m a squared, since this is already equal to 0. X squared, x is already 0. Alright, so from here, since we are looking for the amplitude, we need to manipulate this outcome of the equation. So what are we going to do here, since there is a radical sign? Of course, to break this down, we have to square both sides. Okay, so we have v squared equals cancel, k over m a squared. Since we are after a squared, that means we have to eliminate k over m by dividing both sides by the quantity. Cancel. Okay, this will become m over k mv squared equals a squared. Since there is still a remaining exponent here, we have to extract the square root of each side. Cancel. Cancel. So only the exponent of v squared is cancelled. M and k is still enclosed or under the radical sign. So we have square root of times v equals a. Or we can rewrite this equation into a equals v times square root of m over k, just like the one in the book. Now from here, we simply have to substitute the values we have here to get the value of a, or the amplitude. Alright, so we have v is 0.65 meter per second. Multiply that to square root of 2.5 kilogram over 275 Newton per meter. A equals 0.65 meters per second, and times square root of 9.09 times 10 to the negative 3 kilogram over Newton per meter. So we will break down directly the unit Newton, that is product of mass and acceleration. So we have kilogram meter per second squared over the m here over m. So we can cancel this. So as the m, what's left is the unit second squared. Okay, so square root of 9.09 times 10 to the negative 3 is 0.095. So for the square root of 9.09 times 10 to the negative 3, we have 0.095 seconds. Since we have here the remaining unit second squared, and then extract the square root of this unit, since it is under the radical sign, we will get s, or second, as a result. So this 0.095 seconds multiplied to 0.65 meter per second, we will get 0.065 0.062 cancel meters. Therefore, our amplitude is equal to 0.062 meter. So next is letter B, the maximum acceleration. You have to remember that acceleration is maximum if displacement is also maximum, or if x is equal to the amplitude, meaning it's maximum. So for this, we are going to use equation 8.8, which is A equals F over M, which can also be expressed as A equals negative kx over M, as F, or force, can be expressed into kx. Okay, so letter B. Okay, since we already have the values for the spring, for the force constant, x and m, we simply have to substitute these values to our variables here. But before that, we have to, of course, treat x as a, because it is said to be at its maximum, meaning it reaches the value of a. So absolute value of k over m, and then x is equal to a. So we are going to use the value of a, which we have obtained from our calculation a while ago. And then from here, we have force constant. It is 275 newtons per meter, divided by 2.5 kilogram, and then multiplied to amplitude, which is 0.062 meters. That is 275 divided by 2.5. We get 110 times 0.062. That is 6.82. What happens to the unit? Ako na lang step by step. 275 divided by 2.5 is 110. Newton is kilogram meter per second squared over mass over another kilogram. Cancel, and then cancel, times 0.062 meters times 0.062. We have 6.82 meters per second squared. So the remaining unit here is 1 over second squared. Multiply that to the unit m here, we get meter per second squared, or this value can be approximated into 6.8 meters per second squared. So our acceleration is approximately 6.8 meters per second squared. So next is sample problem 8.6. Here we have a 1.5 kilogram uniform meter stick pivoted at one end, oscillates as a physical pendulum with a period of 1.25 seconds. Find its moment of inertia with respect to the pivot point. Okay, so for this sample problem, we are going to use or deal with equation 8.20. That is not 8.19. In your book, it is written as 8.19. That's just a typological error. So equation 8.20, that is T equals let's start with the summary of the given first. Given is mass 1.5 kilograms. The length of the meter stick, which is uniform meter stick, is equal to 50 centimeters. Or converted into meters, you have 0.5 meters. And the next is the period of oscillation, which is 1.25 seconds. We need to find the moment of inertia. Okay, so we are going to deal with equation 8.20, which is T equals 2 pi times square root of moment of inertia divided by mass times acceleration and the length. So since we are looking for I, we have again to manipulate this equation, and to manipulate that, since we are dealing with a radical, we have to multiply both sides with a square. So T squared equals square of 2 is 4. Square of pi is pi squared, of course. And then this one right here can be cancelled as well. So that will be MGL. Okay. Next is we have to put this I on the other side. Since it is in the numerator, we have to multiply both sides with 1 over I. Cancel. We have T squared over I equals 4 pi squared over mgl. And since we have to leave only the quantity I on the left side, we have again to multiply both sides with 1 over t squared. Cancel. Okay, so it will become 1 over I equals 4 pi squared over t squared times mgl. So we have to cross multiply this. Pwede na ninyo idiretso na lang og balintong. Pero for you to understand the process better, I have to do it step by step here. I times 4 pi squared, and then 1 times t squared mgl. So this is how the equation, which is directly given in the sample problem 8.6, is being derived. So from here, we have, of course, to substitute the values that we have here. So we are looking for I, T, nanitingog ng tiki. T is 1.25 seconds. Mass is 1.5 kilogram. G is acceleration due to gravity, 9.8 meters per second squared. And length is 0.5 meters. It should be in meters. And then 4 pi is 3.14. Okay, square. Square of 1.25 is 1.56. May pagidritso na lang to. Anyway, kopyahan lang sa nato ni. And then square of 3.14 is 9.86. So let's see what units can be cancelled here. We have s squared meter sa paman. Ay, sorry, di makancel ang meter. Numerator man ni pariha. So, mabili na to si kilogram and si meter squared. Kay duha man ni ka meters diri. Ma-multiply na siya, di na siya makancel. So, to simplify, we have 1.56
times 1.5 times 9.8 times 0.5. We have 11.466 divided by 4 times 9.86. So we get 0.29. The unit is kilogram meter squared. Wala ni na-cancel ha. Sorry kay nasayop ko. Numerator na sila pareho. So instead